Hello. Now we're going to discuss about uh, basics terminology of machine learning. We'll also see what is baseline models, and we'll discuss about the decision tree algorithms. That is one of the most profound machine learning algorithms we have. Again, here we are importing few stuffs, right? So don't worry about the imports right now. Right, in the file, whenever there is a need of the particular import modules, right? So we'll import there, right? So we'll discuss where do we need to import the dummy classifier, where do we need to import the decision tree classifier, and so on, right? So what we'll see in this file, right? So we'll try to identify whether this problem is being solved using machine learning or not. Specifically, we'll discuss about the supervised machine learning. We'll see the difference between supervised and unsupervised. We'll discuss about some terminology like the what is features, what is target, what is predictions, training and error. We'll differentiate between the classification and the regression problems. We'll use the dummy classifier and the regressor as a baseline model for the machine learning problems. We'll also discuss what is baseline model is. We'll see what a fit and the predict paradigm is, like what is the fit method doing, what is the predict method doing, what is the score method doing. Remember that we have started this series as a practical machine learning, right? So we'll see in terms of how do we implement machine learning, and by understanding the every machine learning algorithms, right? We'll broadly describe a decision tree algorithms, right? How this decision tree algorithm works. We'll see how to implement this decision tree algorithm using scikit-learn, like the decision tree classifier is there to implement this decision to implement decision tree for the classification problem. Then we have this decision tree regression. We'll see that. We'll visualize this decision tree. We'll see the difference between parameter and the hyperparameter. We'll also understand the concepts of the decision boundary, and then we'll see the relationship between model complexity and the decision boundary, right? So we have a lot to learn in this class. Let's start. So terms. So you will see a lot of terms when you will see with the machine learning, and see there are a lot of kind of theories are there, lot of statistics are there. We have this mathematical way of learning the problem. We have this test kind of statistical way of learning machine learning. Then again, like some problem learns the machine learning by applying it, or by implementing it, right? We just understand the basics concept, and then we'll implement the algorithms using scikit-learn, right? So there are lot of theories around it, lot of terms around it, right? But we'll follow patterns there. We'll try to understand first. We'll try to implement a simple machine learning algorithm or any machine learning algorithm before starting. First we'll try to implement it, and then we'll try to understand the theory behind it, right? So this is how we are going to study all the machine learning algorithms, right? So in this lecture, we are first going to discuss about machine learning model, and then we'll see the first machine learning algorithm is decision tree algorithms, right? We'll see some common terms in supervised machine learning, right? And for that, we'll use the toy data set. These toy data sets are basically we'll use this great quiz to great prediction for classifications, the regression data set, and then the Canada USCT data set, right? So here, let's first download our grade 2 classification quiz to grade toy classification dataset using pandas. Here we are trying to check the shape and the first 5 examples. So the shape is 21 by 8. So we have this 21 rows and the total 8 columns, right? So as a recap, we have this supervised machine learning we have discussed as, right? So where we have the training data. Training data have the two part, X and the Y part. X is the all the features and the data, and Y is the information about the examples, right? Like whether this example belong to cat or not. We pass X and the Y part of the data to the learning algorithm, this which in return gives you the ML model. Now we'll use this ML model on unseen data set, and then that will give you the predictions. So this prediction will only be given based on what it has learned in this knowledge into the training data, right? So as a tabular data, So here is an example of the tabular data where we have this. So again, all the examples we have, right? So we have this example. Sometimes we also call this as n. The X part of the data is called features, right? So we have in this data set, we have this ML experience class attendance, lab 1, lab 2, lab 3, lab 4, and quiz 1. These all are the features. Based on these features, we want to predict the quiz 2. So all the features are called X, and then the quiz 2 is called Y. So based on all these features, we want to predict Y. So that's the reason here all the features are called X over here. And here we also call this as in D features. Like how many number of features we have D number of features, and then we have this Y as in target columns, right? So feature is what? It's a relevant characteristic of the problem, right? So generally we choose as features of for the particular data set very thoroughly, right? Mostly it is being suggested by the expert, or if you are kind of good in understanding those data, then only you are like you will understand that whether this particular feature is will be important for this data set or not. Then we have this targets. What are the targets? It is a feature only, but we want to predict that feature. So that becomes a target, and we denote it, and we denote that target by y value. What are the examples? It's a number of examples, or the number of rows is called the examples. Like how many number of rows we have in this? How many number of examples we have? We have the 21 examples because we have the 21 rows. How many number of features we have? We have 8 columns. In this we have the 7 features and the y, 1 as a target, right? So the total become 8. Now what is training? So training is the process of learning the mapping between feature and the target. So when we say we have to train the model, or we are training the model, that means that we want to learn the relationship between x and the y, right? That is a very simple thing, right? So training means learning the relationship between the feature and the target, or the x and the y. So here we have the example of the tabular data for the grade predictions, right? So here we have this entire data set we have, which include both x and the y. That means both feature and the target. So here first we need to, so the first step is we need to extract the x and the y separately. This is what we have to do as a first task is, first we have to extract separate x and the first we have to separate x and the y both over here. So here we are separating x, we are separating y, right? So we are choosing y, and then now we check the first 5 example of the x and the first 5 example of the y. So now we have separated x and y over here. Here you can see the another data set. So this is our housing price data set, right? So here the price is our y. All the features are the x value we have. So here also, first we'll drop the price and then we'll select the price, right? So after dropping, all the feature will be x, and then the y is the features. So here we have the x and we have the y, right? We can check the shape of the x is this 21613. These are the number of rows, and the 18 are the number of exact columns, which are the features we have, right? And there are the alternative terms we have. So examples, right? In the different books, there are the different terms is being used, right? So we have, again, as I've said, this machine learning as a very broad topic, right? Some people see this topic in terms of like sometimes some people see machine learning with the lens of statistics. Some people see machine learning with the mathematics. Some people see machine learning as in coders, programmers. So all are using a different keywords, right? So examples are also being called as in rows, samples, records, and the instance. Features are also being called as an input, predictor, explanatory variables, regress and independent variables, and the covariates. Targets has a different name too. It has the name as an output, outcomes, response variable, dependent variable, and the labels. Training, learning, fitting, all are the same thing, right? So again, maybe like different books use the different terms, but all are just 4 different categories, right? Here we'll use these terms, right? So we'll use examples, feature, targets, and the training. Sometimes they also use learning and the fitting, right? So what is the difference between supervised and unsupervised learning? So in the supervised learning, right? We in the data set we have both training, like in the data set we have both X and the Y part, right? In supervised learning, in the data set we have both X and the Y part. And now our learning algorithm want to understand the relationship between X and the Y, or we want to find a model function F which relate X to Y, right? And then we want to use that model to predict the new example. That is what the supervised machine learning is, right? In unsupervised machine learning, the data will only have the X part of the model. Here you can see that the training data have X and the Y both part. In the now in terms of unsupervised, the training data have only the X part, right? So in this, we just want to pass this data to the learning algorithm which return the ML model. Now this ML model will help you to classify, not classify, it will help you to segregate both type of data or any type of data, right? So in unsupervised learning, right, we only have the X part without any corresponding targets, right? And in unsupervised learning could be used to group the similar things together in the X. So here unsupervised these learning algorithms will group the similar things together, right? So it will group all the emojis of cat, it will group all the emojis of dogs and so on, right? So grouping things will happen over here, right? So supervised machine learning is about finding a function approximation which relate X to Y, right? Whereas unsupervised learning is about finding the or concisely describing the data, right? So it's like we are describing that, okay, these are the different group, these are the different groups. Here, by looking at those data, now you can label those groups, but this model does not know whether this is cat or dog. These model will only know that this is a different type of data and this is the different type of data. That's it, right? Now let's talk about the terms as in classification and the regressions. In supervised machine learning, there are two kind of learning problems. So one is the, again, here we are talking about the supervised machine learnings. So based on what we try to predict, we define a two type of problem. One is classification and the regressions. So if you try to classify the discrete class or the groups, let's say that here we want to classify a disease or not, cat and dog, spam and non-spam, A plus, not A plus. These are the classes, these are the different category that we want to classify, and that is called, those examples can come under the classification problem. Then in the regression problem, where we want to predict the continuous value, like the house price prediction, it's a continuous value, right? Like the student score prediction, it's a continuous value. These becomes a regression problem. So based on what you want to predict, we have a two type of problem in the supervised machine learning. If you want to predict, again I'm repeating, if you want to predict classes, right, or that so that becomes the classification problem. If you want to predict the numbers, that becomes the regression problem, right? Here is an examples. Here we have this example, this entire data we have here. The our y value is quiz 2, where the values are A plus and not A plus. This becomes a classification algorithms, or this is a classification data. So we want to use the classification algorithm for that. Here the quiz 2 is the simple numeric value. This becomes the regression problem. So we'll use the regression algorithm for that, right? Let's see that examples again. Here we have this classification data, and this data looks like a regression data because here we want to predict A plus and not A plus. Here we want to predict simple numbers, right? Now let's talk about the baseline models. So what is baselines, right? So now, as a quick reminder, in supervised machine learning, we have the training data. These are the training data we have. We pass the training data to machine learning algorithms, right? Here we are passing our data to machine learning algorithms. Now this machine learning algorithm will return you the ML model, right? Here it returns the ML model. Now, after we get the model, now we have the unseen test data we pass this unseen test data to the ML model, and that will give you the predictions. So again, in unseen test data, we only have the information about X. We do not have the information about Y. So this model will predict the actual Y value, or it will predict the what could be the possible Y value for this X data, right? Now let's build a very simple machine learning model for quiz 2 predictions. So here we are reading our quiz 2 grade classification problem in this data sets, right? Now first we are trying to check the value counts of the quiz 2. So here we can see that so the total value counts for the quiz 2 is, so now in the quiz 2 we have the two classes, A plus and not A plus. So not A plus are 11 of those and A plus are 10 of those. So it's like not A plus will occur more frequently compared to A plus, right? Because not A plus is more repetitions. It's a more in number compared to A plus. So it's like if you kind of frequently predict not like, so this, because we have this not A plus more, right? So if you kind of randomly choose the example, right, there is a higher chance that you will get not A plus more compared to A plus, right? So the question comes in, what if we predict not A plus all the time? What will happen if we predict not A plus all the time? And this is what baseline model says. Our baseline models works as a very simple rule of thumb. So it uses the most frequent examples or the most frequent labels in the training data set. So we also call this as the most frequent baseline models, which always predict the most frequent labels into the training set, right? So here, this baseline model we can use just to check how the machine learning model will perform, right? So here we are not using, here we are not building any different logics. We are not using any mathematics. We are just saying that what if our model will predict not A plus always? How much is the chance that we'll get like, what is the chance or what is the accuracy of the model will get, right? So here now, so that is what the baseline model is. Now let's see the dummy classifier. So the dummy classifier is our baseline model for the classification problem, right? So if its dummy classifier is implemented in the sklearn, right? So when you call the dummy classifier, that means you are calling the baseline model for the classification problems, right? So here we just want to train our dummy classifier model. That means when I'm saying training, that means we are saying learning. Remember that we have used the term like train, fit, and the learn, all are same thing, right? So when we say train dummy classifier, that means that we are saying that we want to learn the dummy classifier models. Now let's see step by steps. Here are the different steps as a classifier, right? So first we read the data. The first step is reading the data. Then we separate X and the Y of the data. Then we create a classifier object. Here we create a classifier object. Then we fit the classifier. Then we predict on new examples and then we check the score of the model. Right? Now let's start the first step. First we are reading the data. We have read the data. Now create X and the Y. That means we have to separate X part of the data and the Y part of the data. That means so all the feature and the target we have to separate. So X is the feature and the Y is the target. So here we are separating. So we are just dropping quiz 2, that will give you the X. Here we are just selecting the quiz 2. So we have separated X and the Y. Now let's create a classifier object. So when I'm saying classifier object, that means that here we want to initialize our object. See, all the implementations with the scikit-learn is there with the class oriented, right? So whenever if you want to use any of the machine learning model, you first have to create the object of that class, right? So first we'll import the classifier and then we'll create the object. Here we are importing. So to import it, first we are saying from sklearn.dummy, right? Dummy is the module. Inside this module, this is the class that is implemented. So we are importing dummy classifier. And now here we are creating an object called dummy CLF. This is an object of dummy classifier, and here we are initializing the dummy classifier object, right? As a strategy, we are saying that now we want to use the strategy as the most frequent. This means that we'll use this most frequent techniques to build the dummy classifier, right? After we create the object, now we want to fit the classifier, right? So here, when we say dummy CLF dot fit, and then we pass this x and the y data, this means that when we say fit, this means that we are learning the model. So when we apply the fit method, learning is carried out, right? So if you want to learn any model, you just need to call the fit method, and that's it, right? Here we have initialized this model, or this algorithm dummy CLF, right? This algorithm we have initialized, and now when we say dummy CLF dot fit x comma y, this will learn the model, right? This means that we have learned the model after running the code, and now we want to predict. Now we can predict the output on the new examples. So again, here we do not have the extra new example, so we'll predict on the same x data set, right? So here to predict it, we have this predict method. So here we are using dummy CLF dot predict. We are passing x. Now remember, see what output we are getting. We are getting not a plus always. Why we are getting not a plus always? Because this is what our model has learned. Our model has learned that whatever is the most frequent example, you just have to learn that. That means it has learned that the most frequent example is not a plus. So whatever example you will pass to this model, it will only give you not a plus. Right? That is how the dummy classifier work. Right? So it doesn't matter which type of data you have, but this will give you not a plus always. This is what our model has learned, right? Now we can check the score of the model. Now the score will give you the accuracy of the model, like how much your model is accurate, right? So again, the formula for the score, this accuracy is basically it will check the correct prediction divided by the total examples, right? So it will check how much is the out of all the example, how much is the correct prediction has been happened, right? And to check the accuracy, we just need to call the score function. So here we are saying dummy CLF dot score, we are passing x and the y. We need to pass both part of the data, x and the y both, right? And here we can see that we have got the 52%. And this is true, right? Because earlier we have seen that the total 11 example was not a plus, and 10 example was a plus. So when you look at that, so we have this 52-48 ratio, right? And your model has learned as an not a plus. So basically it has learned like, so if you pass the data, right? So it will says that 52% of the time not a plus. So if so it will says every time not a plus, but out of all those, the 52% of the time will be correct, because that is how our data are, right? So here our accuracy of the model is 52%. Right? We can also check the error. So the whatever the accuracy is, we can check the error. Error is 1 minus accuracy. So it will be 48% approximately, right? Here we are trying to check 1 minus accuracy of itself, approximately 48%. Right? So now you know how this fit, predict, and scores method work. Let's see that again. Here is the general pattern. First we read the data, then we separate x and the y. We initialize the classifier, or like any model, machine learning model, we apply the fit method, and then we check the score. And now after you check the score, here you see that now after you check the score, now you know how your model is performing. Our model is performing 52% of the time, right? So our model is 52% correct. Now let's say that here we are getting a new example. Here we have this two new example. So what our model will predict? So we know that our model has learned to predict not a plus always. So it will predict not a plus for both examples, right? That is what dummy classifier is. So now our dummy classifier is 52%. So again, so there is another way to see that to see the baseline model. So this dummy classifier is also a baseline model, right? So now there is another way to see the baseline model. So baseline model is, so you can see that it's a way to check how your machine learning models, what your machine learning models should give the output, right? So if the baseline model is 52% over here, accuracy, so we can say that without, again, this is happening just by a simple rule of thumb, or you can say that by random chance you can get, without building any model, you can get 52% of the accuracy. So now your task is to achieve higher than that. So that will level up our learning algorithms, or our, so that will kind of gear up, right? So how much accuracy we can get, right? We should always check what is the baseline, right? What is the baseline for the model that we are going to try, right? Because not any machine learning model will give you 100% accurate, so we have to know, right? If not 100%, then how much we have to get. For that we are using the baseline model. Now let's see this another baseline model for the regression part, right? Here we'll build a regression baseline model. So first we are importing the dummy regressor. Earlier we have imported the dummy classifier. Again, reading the data, separating x and y, initializing the dummy models, this machine learning model, applying fit and score. We are checking on the new example. Here we are predicting 86.28 in both the time. Now why it is giving you 86.28? So again, this regression model will use the R2 functions or R2 method or R2 score sometimes, right? It uses the R2 score to give the output. So generally, the if you get the 1 as an R2 score, so it's a perfect model. But our model is 86% accurate, right? According to that, now our model is 86.28, right? So this is what our new example that we are seeing. Again, we'll talk about this R2 score later on in the course, right? But here our output is 86.28. So basically this is what, this is not the score value actually. This is not the score value. This is like the mean value of whatever the data we had, this dummy regressor have taken up the mean value, and it will only give you the mean of the data, right? So here you have to understand in this way. Let's say that if we have the example between 1 and 100, and then the mean value is, let's say that 48, right? So if someone asks, can you just give me 1 point summary for this, you will give the mean value. So dummy regressor will only gives you the 1 point summary for the data. So 86 is the mean value. But when you check the score value, you are getting 0, 0. What is meaning of this? So does this mean that our model is 0% accurate? No, this does not mean that. Because when you check the score value, it uses the R2 score method, right? And R2 score, when you calculate the R2 score and when you get the 0 as an R2 score value, this means that you are 50% correct, right? So the value for the R2 score is, it can go as high as 1 and it can go as low as minus infinity, right? So R2 score value can go be kind of beneath 0, right? So it can go beyond 0, right? It can go to the minus infinity, right? But if you get 0, this means that your model is 50% correct, right? This is how the R2 score value works. Again, we'll discuss about that later on in the course, right? Now we have learned about the dummy regression and the dummy classifier. Those are the baseline model, right? Which will guide you how much kind of like how your model should perform or how much accuracy your model should have, right? Now, the first main algorithms, or the first algorithm as a base algorithm, as a machine learning algorithm that we'll try as a decision tree, right? Now we'll talk about decision tree. So this decision tree is work as, so consider that, right? So again, consider that writing a traditional program to predict quiz to grade. So the condition is, can we do the better than the baseline model that we had just discussed? Forget about the machine learning for a second now, right? Let's say that if you have to write the program to predict the whether a student, like over here, with like to predict this, whether a particular student will get A plus or not A plus, right? Consider that this is the examples we have, right? So we have changed the value of lab 1, lab 2 and all these values into a 0 and 1, right? So here consider that, so 1 means the yes and the 0 means no, right? And here also 1 means A plus and the 0 means not A plus, right? So here we have this 0 means a class, like the student does not have the ML experience. Class attendance means student have the great class attendance. Lab value 1 means a student have achieved a kind of good in the lab 1, same as good in the lab 2. Lab 3 is 0, lab 4 is 1, and the quiz 1 is 1, right? So if these are the parameters, right, so we want to predict the value for the A plus, right? So here, if you have to write a simple logic to predict A plus and not a plus, right? So what we can do, we can say that if a student gets 0 ML experience, class attendance 1, lab 1, 1, lab 2, 1, lab 4, 1, and like quiz 1, 1, right? Then the student will get A plus. Or you can simply say that if the student have got ML experience as 0 and class attendance as 1, 0, right? And then the lab 3 and lab 4 as 0, then he's likely to get not A plus, right? But again, here as you kind of consider this other examples as well, right, you will see that you will have to write a lot of logic, a lot of machine learning patterns you will find, right? Let's say that like you will kind of write this logic using if else statement, right? So you will have to write a big patterns, right? So let's say that if you write this is the first pattern, this is the second pattern, and so on. So there would be the different possible combinations, right? And when you will, like, let's say again, we only have the few example, like we only had this 21 example. Let's say that if we have the 1 billion example, in that case, right, this problem will get pretty difficult, right? So basically you won't be able to solve it, right, by using the simple this programming technique, right? This is where, right, this is where a decision tree algorithm comes in, right? Or like this is where this machine learning algorithm comes in, right? So this decision tree algorithm, it's a machine learning algorithm to derive such rules, right? So decision tree algorithm is one of the algorithm which derived these kind of rules, right? We'll see that, right? It is based on the idea of like like idea of this 20 question games, right? So where we kind of think in a multiple way, right, to come to the conclusions, right? So this decision tree works very much similar to that, right? And again, here we'll also apply the fit method. We also have the predict method, right? And let's see how this how do we build this decision tree algorithm using scikit-learn. So first we read the data, separate x and the y. Here we are creating like copying the x value as an x binary, and here we are transforming our data to the binary data, right? So we have transformed our data similar to this data, right? And now we'll build a machine learning model out of those. So this is our y value. Now, first let's try how our dummy classifier gives you the output. So here we already know that dummy classifier gives us the output as 52%, right? This is the output of the dummy classifier. Now let's try to build the decision tree. So again, to build a decision tree, first we need to import the decision tree classifier from the sklearn.trees. So this is a class, right? So this class has the implementation of decision tree classifier, right? Here we are creating the object of the decision tree classifier. We apply the fit method. When we apply the fit method, this means that we learn the pattern in a data, and when we check the score, that means this will give you the score of the model on that data. Here we can see that now with the score, now we have got the 90% correct. Now our decision tree model is doing great, right? It's a 90% accurate models, right? Now here what we're trying to do is we are just trying to print our our model, or our all the decision tree rules, all the rules that decision tree algorithm has derived. Here we can see that this is a derivation from the decision tree, right? So here this is like, first it has taken the decision based on the lab 4. If it is less than 0.5, then it will take the decision based on the class attendance. If it is greater than 0.5 the class attendance, then it will predict not a plus, and so on, right? So here we have some terms that we need to be familiarize yourself. First is the root node. So this is the first condition that we are checking in the model. The first condition we are checking as lab4. This first condition will become the root node. Then the branch is so branches are the connect the node. So these are all the arrows. So this node and this node is connected with these arrows. These are called the branches. The internal nodes is which means this represent condition within the tree. All these nodes within the tree, all these nodes called are internal nodes. But we also have the leaf node. Leaf node is something that which represent the predicted value when the path from the root to leaf. So these are the leaf nodes. So the last node is called the leaf node, right? From here it has gone to here to here. This become the leaf node. This become the leaf node because from here there is no growing up. This becomes the leaf node. This becomes the leaf node. This is our leaf node. So last node, always the last node is the leaf node. Right? These are the leaf node. And then we have the tree depth is the number of edge on the path from the root node to the farthest to the leaf node is the tree depth. Like here we can see that you can consider that as an this is the depth 0, this is the depth 1, depth 2, depth 3, depth 4, and the depth 5. So we have the 5 level. So our tree has grown to 5 level or till 5 depth. We'll start from here, the depth 0, and then all the way till here. So we have the 5 depth. So we call this as a tree depth, right? So how does predict work? Here we have this new example. Here we have considered the new example. We have converted to a data frame, and now here. Now consider that. So how this predict work in this algorithms? Consider these examples over here, where the ML experience is 0, class attendance is 1, lab 1 is 0, lab 2 is 0, lab 3 is 1, lab 4 is 1, quiz 1 is 1. So the first thing that we will try is here we have the same examples, right? So the first thing that we'll try is lab 4. What is the lab 4 value? The lab 4 value is 1. That means lab4 value is greater than 0.5. This condition is not true. So we'll come to this one. So here we say that if lab4 is less than or equal to 0.5, so we have to come this way. But here our lab4 is 1, which is the greater than 0.5. So we'll come to this way, right? Now we have to check the class attendance. What is class attendance? It's 1, again 1, again 1 means this node now. Now we have to check the lab2. What is the lab2? It's 0. If lab2 is less than 0.5, so 0 is less than. Now here we are getting the value. So here we can see that the last value that we see here, we have predicted the A plus, right? Our model has predicted A plus, or our model will predict A plus. This is how our algorithm work, this decision tree algorithm work. And when we try to see model.predict with the new example here, we can see that we have got A plus over here. So in summary, given the learned tree and the test example during the prediction time, we start from the top and ask each binary question at each node till we do not come to the leaf node. Once we reach to the leaf node, that is our prediction. So how does fit work? So again, this fit works something like that, right? So again, it start with the asking questions based on each example or the most important features, right? First it finds which is the most important feature, and based on that and if the particular feature is most important, right, then it will take decision based on from that, right? The example over here, consider this, right? Let's say that if you have to classify create this mango, banana, cherry, and kiwi, right? So first we'll check whether this is tropical or not. If it is tropical, then we are checking this whether this it has fit or it is a red, right? So here each questions is a most generic question. So the top question will be the highly generic questions, right? Or in other way we can say that the top questions or the top root node, the first node which is the root node will be like over here. This is our root node. Lab4 is the root node, right? So root node will be selected based on if it is highly separable exam of data or not, right? So here we'll check if the both like if the data set is highly separable or not. right? So that becomes our root node. So this is how our fit work, right? So which features are the most useful feature for the classifications, right? So highly possible means here we are checking that which feature is the most useful feature, and to check the most useful feature, right, we want to minimize the impurity of that node, right? So here we check that what is the impurity at each node. That means if we divide the data based on ML experience, how much impurity will get. If we divide the data based on lab 1, how much impurity will get. If we divide the data based on lab 2, how much impurity we get. So in this way, we'll check the impurity based on each features, and the feature which has the lesser impurity will become the root node. And to find that impurity, we use some criteria like the Gini index we have, that the information gain, cross entropy. These are the formula that the decision tree algorithm uses, right, to check the impurity, right? And based on that, it take the decisions, right? Again, here we are importing the decision tree, we are initializing the model, we are fitting the model, and then we are plotting the models, right? So this is how our model been plotted. And here we are plotting the model based on, here we are also printing the Gini index. So here we can check that. So the Gini index at lab 4 is 0.49. So based on the Gini index, right, here the Gini index value is higher, right, like 0.49, which is 0.5, right? This means that lab 4 is highly separable. Like if you separate the data based on lab 4, there will be the minimum impurity, right? And then here we can check that the Gini index is 0.34, right? Out of this, here you can check that the Gini index is 0.44, right? And so on, right? At, and here you can check that. So the minimum at the leaf node, the Gini index value is 0, 0. All the leaf node. So here, this is not the leaf node we have, right? So like here you can see that, right? This node has one A plus and not A plus. So the Gini value is 0.5, right? So each node will have a different Gini value, right? Now let's try the decision tree with the continuous feature with our original data set. This was our original data set. This is not the binary, like this binarized data, right? And here we are initializing this decision tree classifier. We are applying the fit model. We are printing the models. So this is the model we are printing. Now with the original data, without any binary, right? We are not binarizing this. With the original data now, our model thinks that now lab 3 is the most important feature. Based on the lab 3, now it is taking decisions, right? So this is, we are done for the classification. We can also use this decision tree for the regressions. Instead of Gini index, we can use some other criteria, right? So one of the common criteria we can use is mean squared error for the regression problem. Again, what is mean squared error, and like everything we'll discuss later on, right, into the course. But the question is, this decision tree algorithm also support the regressions. To import the regression or to do the regression, we have to import the decision tree regression. And again, we have to do the similar thing like fit and the predict and the score, right? Again, if it is the regression problem, so instead of accuracy, it will use the R2 score functions, right? Again, here we have this data. Again, the quiz to value, we have this 9084. So now the quiz to value, which is the Y value, this is our numeric value. This is no more a class problem. This is a numeric problem now. So here we'll separate X and the Y, right? Now here we are setting the depth to, again, we'll talk about later on what is depth to. We are initializing models, we are applying fit method, and here we can check that the R2 score is 98, it's a 99%. So our model is 99% accurate, right? And here we can check the predicted value, and this is the quiz to value. So the original value is 90 and the predicted value is 90.33. Original value is 84, predicted value is 83. Original value is 82 and the predicted value is 83. So what you see is our model is very accurate. It's a 99% accurate. So this is the best model that we have got till now, right? Now some more terms that we'll see, right? So Now let's talk about what is parameter and what is hyperparameter, what is decision boundary, right? So what is parameter? So parameter is something that is learned during the training process, right? So this decision tree will learn all the things during the training process. Like over here, we have learned that this 83.5, like based on this 83.5, we have to split the features, right? Here we have this 94.5, right? These features are called the parameters because, and now we are also splitting first. So first feature is lab 3, then the quiz 1, then the lab 4. These are called the parameter. All the things that you learn during the training is called the parameters. So when we predict the new example, these parameters will be needed, right? So we need the what is the root node, on what value we had splitted, what is the next node, on what value that next node was splitted, right? How was the criteria, whether it is less than, greater than, right? All these things is needed when you need to predict the new examples. Those are called the parameters. And here is an example for that. Here we have the same classification data set, right? This is our data set we have, and these are the parameters we can see. That these are the parameters we have. And here you will also see one more thing, that by default, all the node you will see, these will be the pure node. What is the meaning of pure node? Pure node means there is no mixed data. Like in this node, here we have this 0 is the A plus and 6 is the not A plus. So all the examples is not A plus. In this, 1 is the A plus and 0 is the not A plus. 0 is the A plus and 3 is the not A plus. 0 is the A plus, 1 is the not A plus. What you will see is in all the leaf node, you will see only one type of example is there, right? Here we have total 8 example and all are A plus, but 0 is the not A plus example. So all the examples will become so because of this behavior, we call this as an pure node, where all the examples in the node belongs to a particular class, not a mixed class. Like over here, this had 9 example as an A plus, but 1 example as an not A plus. This is not the pure node. This is the pure node, right? So by default, when you grow the tree, when you build the tree, all the nodes will be the pure node. That means the tree will grow until it does not classify all the examples into the pure node, right? So the question is it possible to control this learning behavior? And here you can see that one problem here we are seeing that here we only have the 2 examples. One is A plus, one is not A plus. Now to classify this one example as a not A plus, this has built another tree, right? And this node says not A plus and this node says A plus, right? So this is very extreme behavior that we are seeing with the decision tree, right? So even with the one example, it will try to make a new branches. Even to classify the one example, it will try to make a create a new branches. We do not want that. We do not want this much extremism. So is it possible to control this behavior? Of course we can control. We can say that I want the tree to grow at a depth of certain levels. So we can control the tree based on the depth value. These are called the hyperparameter. Like again, consider that here. Here we are getting a model. Again, here we have said that we want the tree grow based on depth as 1. So we want the maximum depth as 1. And when we build the model here, we can see that this is the depth 0 and this is the depth 1, right? So now we have built a model with the depth 1, right? Here we are building model with max depth 3. Here we are setting as max depth 3. Now we can see that this is the depth 0, depth 1, depth 2, and the depth 3, right? So we have built the model with the depth 3. Right? So here we are controlling our machine learning algorithms, how the machine learning will work, how much. So we are controlling with the parameter. Those parameters are called the hyperparameter, right? So what is parameter and what is the hyperparameter? So when we apply the fit method, a bunch of value will be set, right? So it will decide which feature to split on. It will decide what is the threshold value, and all those jargons, those are called the parameter. And what is hyperparameter? So hyperparameter is something which we set before we apply the fit method. Like here, we have set this max depth as 3, right? Here we have set the max depth as 3, right? Because of max depth 3, before we apply the fit method, right? This is called the hyperparameter. Again, there are the other hyperparameter also we have, like the minimum sample split, minimum sample leaf, max leaf node, right? All these are called the hyperparameter, right? Now, what is the decision boundary? So now we know what is parameter and what is hyperparameter. Now, what is decision boundary? So decision boundary is something that we learn from the model. So far, we have been using them to predict the class of new instance. So decision boundary will decide, right? It will predict whether this example will belong to class A or class B or something like that. And another way to think of this is we ask a different type of questions, right? And based on those questions, right, those decision boundary get set. Again, we'll see that over here. Consider that to understand this decision boundary, consider this first example, right? Here we are only taking the subset of the example, like we have taken the two feature lab 4 and the quiz 1. This is the x value we have, and we already have the y value. So this is for the quiz 2. Here we are building a decision tree with the max depth as 1. We're applying fit method, and then here this is called the tree and this is called the decision boundary. Now here our first parameter that used to get divide the data is lab 4. Here is our lab 4. So first we'll check that if lab 4 is less than equal to 84.5, so that will come. So those example which comes under less than 84.5, those example will be not a plus. Here you can see this boundary. This is the boundary of 84.5. So all the example which is on the left side of this 84.5, these example will be not a plus. And if the example which comes greater than 84.5, these example will be a plus. And here you can see that. So all the example you can see here, we have in this category, we have the 10 example as an a plus and 6 example as a not a plus, right? So here you can see that, right? So this is the decision boundary we have, right? So first decision boundary is 84.5, this parameter, right? Let's see with the max depth 2. With the max depth 2, we have this 2 parameter now. Now our model gets decided based on the 2 parameter. First is lab 4, and the second is if lab 4 is less than 84.5, so all these example will come under this category. But now again we are dividing this example, we are further dividing with the quiz 1. We're saying that if it is less than 83.5, right, then it will be not a plus, otherwise it will be a plus. And here we can see that here this quiz 1 is less than 83.5, so all these example will come under not a plus. Even though this example, this a plus, this example belong to a plus, this example the model will predict as a not a plus because it has learned so far, but all these example will be predicted as an a plus even though it is not a plus, right? So these are called these rules are called the decision boundary, right? Here we are getting the decision boundary as max depth 5. Now as you will increase the hyperparameter, this max depth, or as you will grow the tree, you will see that the tree growth has been increased, but then this hyperparameter has also so this decision boundary is also getting complicated over here. We can see that, right? Now let's talk about another example. We want to predict a country using longitude and latitude, right? So here we'll use this Canada US city data set. So we want to predict based on longitude and latitude whether this particular example or this city belongs to Canada or USA. Here is a data set we have. In this data set we have this longitude and the latitude value, and then this will become X, and then our Y value is the country, which is the USA and the Canada. Now again here we are separating X and the Y. This is the how our data looks like, right, based on longitude and latitude. So these example, all the blue circle will is Canada, and all the red triangle is the USA data set, right? Now let's see. But again, remember that this is not the real boundary of the Canada US. The real boundary of the Canada US is something like that, right? But consider our example over here. Here, first we are building a decision tree with the max depth one, and now we are printing that. Again, these functions that we have been using to print it, right? This function is available in the utils modules, right? That is available with the code, right? So you do not have to remember this, right? So, and again, these functions have been developed just to kind of draw the graph and for the explanation. In the real world, you do not have to build these kind of graph, right? So now here we can see that here we have taken with the max depth one. So first decision has been taken based on the latitude, right? So first decision we are taking based on the latitude. It says that if it is less than equal to 42.5, then it is not a plus. When I'm saying not a plus, then it is USA. Otherwise, it is A plus. Now here this A plus and not a plus that we are seeing, which is not true, right? We should have seen as in Canada and the US. But consider that when it says the not a plus, right? It says that it's a USA, and when I say A plus, it's a Canada, right? So this red, so this blue circle is depicting the A plus or the Canada USCT data set, right? Again, we are building a decision tree with the max depth 2 here. You can see that again. Now again, the data is different, but again here we can see that the label we have forgot to change the labels. But anyway, here you can see that now the first decision was taken based on latitude, the second decision was taken based on the latitude and the longitude both, right? So here now this makes sense that these two example belongs to Alaska, which is the USA part, right? So it has separated these two example first. Now it has separated. So these part is comes under the Canada part, and these parts comes under the USA part, right? So this is how our decision boundary looks like, right? And this is how a decision tree algorithm works. So as a final comment in the summary, what we have discussed today, we have discussed a lot of terms in the machine learnings, right? We have discussed what is features, what is target, what is examples, what is training. We have also discussed about supervised and unsupervised machine learning algorithm. We have discussed about classification and the regressions. We have discussed about accuracy and the error. We have discussed about parameter and hyperparameter, what is decision boundary. All these things we have discussed, and I hope all of you will find useful. And like all of you will understand this, right? Now again, we have also discussed about the baseline model. So what is baseline model? So basically it will serve as a reference point for the ML workflow, right? So let's say that if you are building model, but let's say that if your model is 87% accurate, but let's say that your baseline model gives you 90% accurate, right? So there is no point of building a machine learning model which is giving you 87% accuracy, because your baseline model gives you 90% accuracy. And how do you understand the baseline model is? So our baseline model is something as, consider that it is just like, so baseline model will be built without using any machine learning technology or without using any machine learning, right? It is just a simple algorithms, right? Or simple rule of thumbs. And what did we learn about the decision tree? In the decision tree, we learn about that it's a model which predicts by looking at the features and the threshold value, right? It learns similar to the questions, right? We ask to find a to kind of solve a task, right? It also have the hyperparameter like the max depth or the other parameter is there, right? And yes, this is it all about the decision tree and the terminology, right? So this decision tree algorithm was the first algorithms, right? We had discussed, right? And yeah, thank you very much.